just need to know when to put the next one out.
Okay.
We don't need 15 seconds.
5 seconds, good.
So after the end of that.
Oops, thank you.
Do a little shooting tomorrow somehow.
We'll have to get the range set aside down there.
We can do this over again if it doesn't work, okay?
Oh, that's
All right.
good.
All right. The major goal that I'd like to address ourselves to is getting a description from you of your career as a small arms and now large caliber weapons designer. And what I'd like to do is take you back to the beginning, and we'll try to sort of work our way to the present.
Okay.
And we'll try not to tax your memory too much, so we can do this in generalized terms. I guess the first question that naturally comes to mind is, how did you get into the business of designing small arms instead of being an engineer designing other things?
Well, I think it was a kind of a hobby that got out of hand, where I always was interested in small arms, and even as a kid did a certain amount of playing around with new ideas. And then, of course, I kind of migrated into that during the time that just prior to going in the service in World War II, and then was in Ordnance at that time in the Marine Corps in World War II, and had opportunities in those jobs to do a certain amount of experimenting on different types of machine guns and so forth, and build a prototype here and there. Then it was still, when I got out of the service, I went into engineering, but mainly in the aircraft field, because I worked in the aircraft field prior to going into the service. And when I ended up with a small company doing specialized aircraft equipment, which I own part of, I had a nice shop available, and I started building some prototypes, such as this prototype of the AR-10. And this was still I considered a hobby. I was making my livelihood really at that time designing aircraft equipment such as valves and motor-operated valves and things like that for fuel systems and air systems for aircraft. So finally the opportunity came along where Fairchild Aircraft had gotten together with a fellow by the name of George Sullivan, who had some ideas on lightweight weapons, and I had met George kind of accidentally at a rifle range one day, and I was firing some of these prototypes, and he got interested and said that he was starting a division with the help of Fairchild, and would I be interested in taking over the engineering. So I said, great, this was where your vocation, your avocation could kind of meet. So that's how I really got started in it. I took some of my ideas over to this new company called ArmaLite, which was a division of Fairchild. And we started using some of George's ideas on mainly, he had some foam fill fiberglass stocks he was putting on some weapons. And then I brought my ideas in on automatic weapon mechanisms, and we kind of started out.
When did ArmaLite get established?
Oh, that would probably be like 55 or somewhere in that neighborhood.
And you experimented with a series of experimental lightweight weapons, and the first practical rifle version was the AR-10, is that correct?
Yes, I had a couple of weapons designed before that and built, such as sporting weapons and 30 caliber. But in fact one of the first things we did was we took one of those designs and made it for the 308 or the 7.62 millimeter, and tried that out with the lightweight stock and so forth. And Incidentally, that design incorporated an aluminum receiver and some of the lightweight ideas and bolt system that was similar to this, so that it did make a very lightweight weapon, but and met the criteria for weight. But being conventionally stocked and a lot of other things, it really didn't do the job for a new military weapon. Fairchild wanted to get into the military business, but along with commercial. So we had design activities going on in there that were encompassed both. And when I finally got together a what I call the AR-10 design with lightweight receiver and all that, that's when this particular weapon got together, and that really started getting the military excited to, and got actually Fairchild excited too, to where they started supporting that program. At that point in time, the Army was thrashing around trying to come up with a 7-pound full automatic NATO caliber weapon. Well, we all know the practicality of such a thing because of its weight and recoil. But anyway, with the AR-10 design, using the lightweight materials, we did come up with a 7-pound weapon. And after we did put it together, it was tested at Springfield Armory, everybody kind of decided that thing is really a little on the light side, even though we had a muzzle brake compensator on it and all that. But it did meet their criteria. But like a lot of other things, once they had it in hand, they were all rather dubious about whether this is really what they wanted or not.
In the latter days of what the Army was calling the lightweight rifle program, which produced the M14,
Right.
and which the AR-10 came into that program at the end and competed with.
It was, very late in that program.
Very late in that program. Your goal was really to develop a conventional caliber lightweight weapon. As you say, one of the difficulties is that the recoil of the 7.62 isn't compatible with that lightweight weapon, and in fact the Army wound up with the M14, which was almost as heavy as its predecessor, the M1, simply because of that weight problem, and they didn't issue it as an automatic weapon. How did you make the transition from an environment where you are doing something with 7.62 to a smaller caliber? How did that come about?
Well, that was relatively easy to scale down. Might add some of the reasons that we did go to this straight line stock thing was the fact of the automatic fire problems they had. You could predict that they were going to have them. So that was the reason to go into this straight line stock rather than the conventional stock system that I originally had. And I knew if they did get a 7-pound weapon that you'd need every, available means and crutch, if you want to call it that, to control the thing. So that's the reason we went to a muzzle brake compensator. Unfortunately, we don't have one of those around, but it's very similar to what people are doing today, and the straight line stock. The other thing is, I might add, I think my aircraft background experience allowed me to get into some of these lightweight materials. For instance, forged aluminum receivers, which were rather unknown at the time in weapons, but it was nothing particularly new to what I've been doing all along in the aircraft equipment, and the fiberglass and all that. They were more or less materials that I'd been using all along, but weren't very well accepted or used in the gun business. So that allowed that to attain the goals and everything they wanted. Getting back to the question on the small caliber, after we demonstrated this, and this weapon was tested at Springfield, incidentally, it wasn't too long after that the Dutch came over and made an agreement with Fairchild to actually pursue and build this weapon as a military weapon. That came about in kind of a backward way. Fairchild had a license agreement with the Dutch to build the Fokker F-27 aircraft. And so they thought this was just a reverse agreement that they would go ahead and license the Dutch. And the plant that they and the company was this artillery in Richtingen, which was one of almost like what we call a GOCO plant. It was a government-owned, contractor-operated or civilian-operated plant. So it required some endorsement by the Dutch government in order to do this, but they had the ins because of the F-27 program. So this thing did kind of get off the ground as a production weapon in Holland. And this weapon you see right here is one of the typical AR-10s built by the Dutch. And once they got it, they changed things around. First of all, they didn't have any requirement for the 7-pound weapon. They liked the mechanism and all the rest of it, and they also had strict requirements to put a grenade launcher capability on and a bayonet. And they also had a very rugged stock. They got away from the fiberglass stock that we had, and they didn't mind adding another pound or so because they had to launch a full-size rifle grenade against a railroad rail, which meant that nothing gave and something had to be pretty rugged, so they had to go to the stock to stand up. So they ended up with a weapon which was still lighter than the M14, but it was considerably heavier than the 7-pound weapon. Well, anyway, this thing got underway, and we got a lot of exposure, a lot of testing on it. So when the Army approached us, it was actually the first approach and interest that I knew the Army had in a small caliber weapon was that we got a visit one day from General Wyman, who was a 4-star, who was in the Konark commander in our plant in Hollywood. And he just came in almost unannounced with a whole entourage and said, hey, how would you like to get in on a rifle program for me? And I said, well, tell me about it. And he said, well, I'm interested in going into something in a smaller caliber to meet future requirements. And he said, I can't tell you all the technicalities, but he says, I want you to go to Fort Benning, Georgia, to the infantry center and to sit down with the infantry board. And he says, they'll tell you all about what they want. And he said, then I want you to get back with me and tell me what you can do for me and how long it's going to take. So I made a trip down there and talked to the infantry board, and they gave me test results and some tests that they had been running for some time on small calibers. And I think you're aware what they were. They were neck-down carbine rounds at the 22, and even taking the NATO round and scaling it to 22 to see what it would do. And they were very interested in this type of weapon, and they actually, their requirements said that they wanted a 6-pound fully loaded weapon with 20 rounds of ammunition in it that had to meet their criteria, which was they had discussed with me, what's range, penetration, etc. They didn't define the cartridge at all. They said, we know this one, which was a 30 caliber neck down, was much too big. The other one was a little bit too small. It was quite obvious that something in between was what they needed. So I looked, when I got back, I looked up what was available in cartridge cases and so forth, and then it looked like the 222 was rather an obvious choice. It didn't take much figuring to figure that out.
Okay, the 222 was a Remington sporting cartridge, right?
Yeah, it was a standard round. And it looked like what it really needed was a military bullet. So I designed up a bullet, went over to Sierra Cartridge, our bullet company in close by in Whittier, California, and they said, sure, we'll build you one. So they took my prints and built up a bullet. And we took it out, loaded it up, and fired it in a conventional rifle and found out it would do just about everything that they were asking for. Fact is, we were able to accomplish everything they were asking for. So then we went to Remington and Winchester and asked them for quotes of loading this bullet up into commercial cases. Well, they did, but then they hesitated on delivering any because what happened was that we were getting the pressures up a little higher than they liked. So they came back with a bullet with a cartridge with a slightly larger chamber size. That alleviated getting the pressures up higher. They could put a little more propellant in and a little different type, slower burning, and get the velocities that I was asking for to get the penetration. That was the main criteria of the velocity at the time, was to get penetration of a steel helmet at 500 yards and also go through 10 gauge steel plate at 500 yards. So that kind of determined that, and I said, well, I have no objection of going away from the standard cartridge case if that's what you want to do. So they did, and that became the 223 Remington as an identifier, so it wouldn't get mixed up if somebody in the marketplace, although they had no intentions of ever commercially building it. So one thing led to another. Incidentally, they were aware of the AR-10 down at the infantry board, but it didn't look like a conventional rifle. And believe it or not, that had a lot to do with acceptance. So they said, can't you take this technology and put it into something more or less conventional? And I said, well, I have a design that we've tried out, but I didn't like the recoil characteristics. It tried to climb and all that with a conventional stock. And I said, I don't care much for it, but at least it looks conventional. And they had seen the 7.62 and said, well, let's do that. So I built one in the shop, more or less scaled down the other. And when the weapon was all together and firing, everybody decided it wasn't as easy to control as they all expected. And so we decided, after the test firing and everything on that weapon, that it might be a lot better to scale down the AR-10 design to that cartridge. So we did that, and that became the AR-15. And so that design, even though it looked a little far out for that time in history, didn't look too conventional. At least it was easier to handle and full automatic fire, which was a requirement at that time. And generally the mechanism was simpler with this type of gas system and all that. We'd pretty well proved that all out in the AR-10 by the time the 15 came along. So that's how the 15 really got started. They gave us a contract then to build, I think, about 12 or 15 weapons, and I took them down to Fort Benning, and that's the first place they were tested by the Army under the auspices of the infantry board. At that time, the rest of the Army, such as Springfield, Aberdeen, and all, weren't even involved. This was a complete shortcut to the system because the benefactor on the thing was General Wyman, who had 4 stars that had a lot to say what was going on in the Army. So eventually, when we got going on the test at Fort Benning, which was really like a mini troop trial test, more or less practical application rather than engineering, they started a test, a coincidental type engineering test with a couple of the weapons at Aberdeen. One of the earliest ones I've ever seen, I think.
Let me just add an anecdote to this series of stories you've been telling. I had the opportunity to interview Ralph Clarkson in 1963. He was the designer of the Winchester lightweight military rifle, which was a conventional design, basically an overgrown M1 carbine in terms of design. And he alleges that the AR-15 won out because the Army didn't want conventional weapons, they wanted something that was sexier. And he said the AR-15 was the better weapon because it had sex appeal. I've always thought, yeah, that's an interesting opposite view of the universe from probably what you were actually hearing, but it depends on where you are in the scheme of things, what your opinions on these weapons tend to be. Let's set the scene a little bit in that period. We're talking 1958 when you're involved with what the Army was calling the Small Caliber High Velocity Project, or SCHV. And at that time, Benning was taking a much more aggressive stance than they had up to that point. you have in 1958 the M14 just having been adopted and the Army not being terribly happy with it. Benning represents the user community, the infantry, and on the other hand you have the Ordnance Corps, which has the technical responsibility for developing weapons such as rifles, machine guns, and the like. What was the attitude of that technical community, which is represented by Springfield and the Proving Ground and places like that, to the AR-15 when it first appeared?
The attitude?
Reaction, maybe is a better word.
Well, actually, they stayed completely away from it. They were, as you know, they were trying to get the T-44E4, which became the M14, really adopted and underway. And they kind of felt that the AR-15 was kind of a passing fancy of some of the people at Fort Benning, and that would pass, that the Ordnance Corps group and the group in Washington, Freddie Carton and Stuhler and all those people were sticking right by the M14. And so they really didn't interfere much, except when they had their chance a time or two on some of the tests that they didn't help an awful lot. In other words, they tried to be a little bit of obstructionist, but they were trying to protect their turf. So they really didn't say much. They didn't say anything hardly against it, but there certainly wasn't anything for it. They just thought, like I say, that this was just a passing fancy, that the Army would go back and settle down and take the M14.
There is, in the scheme of weapons design and weapons development, the issue always of timing, being in the right place at the right time. In the case of the AR-15, that came into being at the tail end of Project Salvo, which had led to those experiments with the .22 caliber and a series of other projectiles, but primarily the small caliber projectiles. Do you think primarily that the ordnance types were assuming that once they got the M14 into production, that discussions such as were being proposed by Salvo, R&D studies, that would go away for a while, and that really they would get on with the production of a new rifle, and it would be sometime down the road before they would talk about a new weapon?
Well, I don't know. That's a difficult question to answer. First place, my opinion is that they had to get the M14 in production because they had to feed Springfield Armory and so forth. There's always that consideration, and that was the immediate thing. The user had said that they certainly didn't want to continue on with the M1 rifle. And the irony was they ended up with a slightly improved M1 rifle, but the main thing was to get production. And so they touted the M14 as being the answer to a family of weapons. It was supposed to take the place of the M1 rifle, the carbine, and the grease gun, the .45 caliber submachine gun, and the BAR. And everybody was in the business knew it was only going to take the place of the M1 because it had to fire it full automatic. There was hardly anyone that could handle it. They always made very favorable demonstrations with it because they had people that were very, very highly trained firing the thing full automatic fire, and they could put on a pretty good show, but when they tried to give it to ordinary troops, it was just useless. But they were determined that they wanted to get something moving in a hurry. In the meantime, the whole salvo/spew program was starting to come up, which is you're familiar with, which was the flechette firing weapon with a combination area fire weapon. And that was going to be the ultimate answer so many years down the line. And they were hoping that this M14 production would last long enough to keep people busy until they got this very, very futuristic type weapon developed to the point that they could produce it.
Well, then in 1958, 59, that time period, what did you and the people at ArmaLite think the future of something like the AR-15 really was?
Well, I think we were, at least I was, I really wasn't convinced that the small caliber was going to make it because of the prejudice of having the larger caliber and all the weight behind that system. And we felt it was a nice opportunity to get in there and show the Army that, or the user, that ArmaLite could indeed, with their ideas, produce weapons that would, you know, function properly and would give them the lightweight capability. And as you know, the politics finally did prevail in the choice. Actually, General Wyman's opinion was that he would stop the user from taking the M14 if the small caliber weapon would perform. And I think there were a lot of people changed their minds and were very enthused about the small caliber weapon, but at the last minute we had a very disastrous test up in the Arctic, which was really, in my opinion, was a completely rigged thing. And I think I told you some of the history on that before.
Well, you can repeat some of that.
Well,
but I think it is indicative of.
At that time, what was happening was that, first of all, I told you the Springfield Armory Ordnance community wasn't really concerned about the AR-15. First of all, they didn't think it would perform because it never had been field tested before. And in Fort Benning, we ran some tests there, or the Army did, that were pretty severe as a user test. And the interesting thing was that the first time the AR-15 ever went out and tested, it completely outperformed the T-44 or the M14, which was their answer, by the way, to the FN, which really won the Army's competitive tests some years before and made the Army look pretty bad with what they had to offer at that time. So the 14 or the T-44 was their best effort, and it finally won. And they didn't really think that this new little rifle would have a chance. Well, it did. It did perform. And it performed very well, and it did give them what they wanted. And so the deal I had with the Army was at the time that I would be present on all the testing because we didn't have the opportunity to have any field manuals, instruction manuals, or anything. And I would go there and introduce the weapon to the people that were going to do the testing, show them how to fire it, how to maintain it, and so forth. And that was our arrangement. And the Army was glad to do that. Well, it was tested several places, and then eventually was going to go to Fort Greely, Alaska, which was the Army's winter proving grounds. And they said they would ship the weapons up there, and they would let me know in plenty of time to go up there and indoctrinate the test personnel. So I remember one day, just about 10 days or so before Christmas, I get this telegram that says in effect that they're having all kinds of problems with the AR-15 rifles at Fort Greely. And I was a little bit stunned on that. So I started making some noises and immediately got invited to go to Fort Greely, Alaska. So I flew up there, got on the base. They outfitted me up in winter clothing, which you really needed just before Christmas up there. And went out and looked at the weapons, and I couldn't really believe it. They were really a shambles. They'd been taken apart. The sights, which are held on with taper pins, which is no reason for them to ever be disassembled, had been taken off the weapons, and pieces of welding rod and things were stuck in their place, which meant that the parts were misaligned. It couldn't make the gun couldn't function properly. You certainly couldn't hit anything with them. And a few other things like that were done, and I asked the test officer, I said, "What's going on? You're not supposed to touch these things until I was here." And he said, "Well, we decided we'd do a little bit of firing, had a little bit of trouble, but not to worry, because now that you're here, if you can straighten this out, we'll get on with our tests." And I said, "Well, okay," and I really felt I was doing this test officer, who was a fellow by the name of Connie Ito, a favor of not getting him in trouble. And I says, okay, I brought enough parts along. I says, let's get the things fixed up, and we'll get them firing again. In the meantime, I was told to go over and introduce myself to the commanding officer of the base, who was a bird colonel. And it was a very interesting meeting. The bird colonel, I forget his name now, I think, said, I want to tell you, Mr. Stoner, that I've been directed to support you while you're here. But he says, that's all. He says, I also want to tell you personally, he says, I think you're doing a great disservice to the United States Army. And he says, by bringing along one of these small caliber weapons, which is going to be a danger to every American soldier that carries one. And he says, I can't wait to get your ass off this base as soon as you can get this thing settled. Please leave.
Yeah.
I mean, he made no bones about the fact how he felt about small caliber weapons.
Yeah.
So he set the tone, and we went on from there. I knew where I stood. What I didn't realize was the fact that after I got the weapons firing, I got a hurry-up phone call to immediately proceed to Fort Monroe, Virginia, to testify at what they call the Powell Board. And I didn't even know what it was, but it was General Powell, who was then the Konark commander, had taken the other Wyman's place. And General Powell was supposed to determine what to do about the future rifle. No one told me a thing, what was expected or what was going on. So I flew all the way from Alaska down to there, which this was in the days of propeller airplanes. It took a while, and I got in there and got called up before this board. And General Powell knew I came from Alaska, and he said, well, how did you find things up there? And gave me kind of an opening to say whatever I wanted to say about the test going on in Alaska. And not knowing anything but what they told me, that they really hadn't begun the test up there, I proceeded to protect these people and said, well, I found some difficulties up there, but I straightened them out, and I think they'll get along all right. Well, I found out that that was one of the biggest mistakes I ever made, because I found out about 2 or 3 days later the tests were all completed in Alaska, and the only damning report on the performance of the weapon came from Fort Greely. They'd already run their tests. They'd fouled up the weapons completely with these homemade parts, complained about the accuracy, complained about the performance and reliability, and written their report, and that was there, and the Powell Board had already discussed it, and in relation to what should they really go ahead with small caliber, or should they just forget it for the time being. So I didn't know that until several days later, after I'd testified there and told them, you know, that things was going to be all right. So then the General Powell said, well, I guess we're really not really ready to go ahead on the small caliber, but he says, I've been insured by the Ordnance Corps and Winchester, who happened to be the loser in this program, that they have both decided that the .22 caliber was just a little bit too small for the Army use, but they have a solution to that, which is a 6mm cartridge. Said, can you build one of these rifles to shoot the 6mm? Well, the 6mm was actually just in between the AR-10 and the AR-15 cartridge-wise, and I said, well, it's obvious we've done both of these. They said, well, would you get on with this, and you'll be getting your instructions on what the cartridge really is from either the Ordnance Corps or Winchester immediately. They're working together on this, and would you go back and start designing this thing, and we'll get on with a small caliber thing. So I didn't know exactly what to say. I knew we weren't out of the running, but at least we had some hope by going to the 6mm. So I went back to my shop, and no 6mm cartridge. I called up Olin or Winchester at the time in New Haven and they said, oh, yeah, we'll get you something in the mail. And they sent me a cartridge drawing. So I started doing layouts of that, and about 3 or 4 days later, they sent me another cartridge drawing, which was a little different than the first one. About a week or two later, I get another cartridge drawing, which was a little different than the other ones. And this kept going on for quite a while, and I guess being a little bit dense, I didn't realize what the routine really was until I read in the paper about a month later announcing the selection of the M14 rifle and the production. Then I get a call from one of the ordnance people and said, oh, well, our little ploy worked pretty good, didn't it? In other words, it got me out of the picture, out of the way, on this 6mm, which was strictly a red herring, turned out. They had no intentions of doing anything about it. And then they got on with their production contract. So the AR-15 became dead for quite a few years after that. But it came close if it hadn't been for that, I think, that one thing up there at Fort Greely.
So one of the lessons learned if you're in the business of offering a product to the military is you really need to be there at all times. And you can't afford to have them testing your weapons, in effect keeping you out of the picture. Although this seems to be traditionally, especially in the last few years, one of the things that the testing community wants to do. They want to isolate the contractor from the actual test procedures when they can.
I think that even to date they're still trying to do that, which I think is completely wrong, because the contractor has an awful lot to offer as far as the way the weapon should be tested or handled or whatever. And also, I know from my experience that every test I ever went on anywhere in the world, I learned something that would be beneficial to the design of the weapon, or, you know, a modification, or the next generation. You know, you can't help. And that's you can't get that experience any other way, reading reports or all that. They're not the same as being there. I think it's extremely important.
You tell one story of the young private who was disappearing from the test scenario very early because his weapons kept failing at Fort Benning. Would you care to repeat that one? I think that's a good indication of what you're going to be up against in the testing world.
Well, that was rather amusing in a way. But
yeah, in fact, at some point we'll talk about how Connie wound up going to. Could you tell us about your experience with the young private at Fort Benning when they were testing the AR-15 down there? I think they were going through the infiltration course where they were crawling around in the dirt and dust and everything.
Well, yeah, that was a pretty good example of what happens in some of these test programs, where the people, you know, no matter how observant they might be, but things get by them. And what was happening was that there was a very difficult obstacle course that they had to drag these weapons through. They had barbed wire strung on the ground about just a few inches off the ground, very tight. And the test troops had to drag these weapons through under the barbed wire, in through mud puddles and sand piles, and come out on the other side and fire so many shots, and then back through this course again, come up to another point and fire. And meantime, you know, things are getting pretty dirty and dragged through. And I noticed that one shooter who was picked was one of the privates there, who, talking to him, probably had the least amount of mentality in the bunch. They tried to pick a cross-section from the very brilliant down to the, I guess you'd call the near moron level, and also different skills of firing to be fair about it, so that the weapon would get exercised and used by all classes of people. They actually studied this pretty well before they picked the troops out down there. It was very interesting. Well, anyway, this kid, I would have given chances that he was at the bottom of the group, except that the rules were, after the weapon failed to a certain point where it couldn't be fired anymore, the shooter would get to go sit under a tree and drink lemonade, and this was, you know, kind of a hot day. And I noticed this young guy spent most of his time sitting under the tree and taking it easy, watching his buddies out there going through all these obstacle courses, and while he was taking it easy. And his rifles never lasted long at all, and I thought there was something peculiar going on. And each shooter, by the way, had a sergeant standing right behind them and observing their shots, any malfunctions they had, where they were hitting and so forth. So they were being watched pretty carefully. So I decided this guy probably would bear some extra watching. So I went along and I was watching what was going on and what this young man was doing. And he knew that the quicker that weapon failed, the quicker he could get over there where it was comfortable. So during this, usually would drag the weapon along with the front sight, and we get ready to fire, and he'd fire a magazine out, and he'd take his magazine out of his pouch, and he would always kind of stumble or something, and he would scoop up the magazine full of sand, and always turn the weapon upside down and shake it real good while it was upside down, so he could get the benefit of all the sand he could get inside the weapon. And he did this every time. He always managed to scoop up the sand or the mud, turn it upside down, and fire it. Well, the weapon didn't last very long doing that. And I was told not to interfere with the testing, but it's kind of hard to keep your mouth shut all the time. And I got this big staff sergeant who was I would call a typical redneck type. I got him, I says, would you come over here for a minute? I want you just to watch something, what's going on. And this fellow observed, and he caught on very quickly. And I thought there was going to be a young private stomped all over there pretty quick, because there was all kinds of threats to his health at that moment, and all that stopped. But it was a good indication, though, of what can happen, and for the reasons. In other words, the basic reason there was to make the system fail as quick as possible so you could go sit in the shade.
So objective testing can be very difficult.
It can be very, very difficult. Quite true. And this objective testing doesn't stop right at the shooter, but it also, the way tests are designed, we've talked about that and other things where they can be designed to favor certain weapons or make certain results come out the way you want.
Let's talk about ammunition for just a second, since we have both an early Colt AR-15 in front of us and the Dutch AR-10. We have a couple of dummy rounds here which give us some size comparisons. Let's take a look at those and tell me what you gained in terms of advantage when you went to the smaller cartridge.
Well, as you can see here, it's quite a difference in size, and there's about exactly, I think, a 2-to-1 difference in ammunition weight, which means a rifleman not only has a lighter weapon to start with, but he can carry twice as much ammunition. The other thing is that the impulse, or the amount of recoil, is considerably less on the smaller weapon, so therefore in automatic fire the accuracy can go considerably higher than the 30 caliber. And there are some other subtle things that come up too. Basically the wounding capability of the small caliber is not disproportionate to the large caliber weapon. They're, in most practical cases, are almost identical because of the velocity difference in the lightweight bullet.
Let's talk about practical differences. One of the things that the Salvo program did was to point out for the first time in fairly straightforward analytical terms that people do not shoot weapons in combat at the ranges that they have been traditionally taught to shoot. For example, when you get into combat, most of the shooting is done very close in, it's not done at long ranges. When they were testing the AR-15 and the AR-10 at Fort Benning, I believe they discovered that, and as a consequence, they changed some of the targets in order to accommodate for that. Could you sort of relay that story again?
Well, going back to the basic background on why they were going to the small caliber was rather interesting. The salvo reports and some of these other reports reflected the fact that the long ranges were not common in combat, that the 30 caliber cartridge was really scaled down, as you know, from the old .6 size, which really had to have capabilities out to 1,000 yards, and mainly the 1,000-yard figure came about because it was basically used in the machine gun, and the machine gun in the old days was used like artillery to lay down barrages to deny enemies areas, not just, you know, point targets. And it was very convenient to make the rifle shoot the same caliber for logistics purposes. But what they had discovered in the salvo reports, and also this was confirmed by the infantry board people, that rarely was anybody ever hit with a bullet beyond 300 meters or 300 yards. You didn't see the targets, you didn't have the opportunity, and you certainly couldn't hit them. So what they were trying to do in that early day, like we're still trying to do, was to tailor a weapon to where it was needed the most, and not be burdened by carrying around a bullet that was conveniently a good long-range artillery round or machine gun round, but actually tailor it to the user in what way he was going to use it, being the infantryman. So they had decided this before I ever got into it. I was surprised at the ranges that they decided. They decided at the board that 300 meters was it, but they could not get it boarded. They couldn't get the program started, they didn't feel, at 300 meters, so they recommended a Konark, a 400-meter system, because they didn't think it would fly. And Konark didn't have nerve enough to send that recommendation to the Pentagon, and they made it 500 meters. So that's how this cartridge was actually tailored, not around the most useful range, but actually 200 meters beyond.
And when they got to Fort Benning and were firing the M14 against the AR-15, when they got out of those ranges, say 500 meters, what did they see when they were shooting at targets that sort of looked like olive green uniforms? What did they see at 500 meters?
Well, the problem was they actually brought in the real long ranges. They brought them into about 500 to 600 meters, the E-type targets, pop-up targets. And what happened there in the summertime at Benning, no one could see the targets sitting out there in a green field or in a woods at that distance. They could only see them at 200 and 300 meters or 25 meters away. So became very obvious. And so what happened was very curious. The people that were advocates of the large caliber weapon, and this was a big issue, and it's hard to explain, but it was very emotional, a big issue of whether we should even consider going to anything smaller than 30 caliber. Those advocates said, what you're doing by presenting targets like that, you're actually giving it an unfair advantage to the small caliber gun, because we all know the big caliber gun can shoot further, so therefore it should have targets to shoot further, whether that was the real world or not. So they decided to paint the targets white with black crosses on them so they indeed could see them at long ranges. And I said, well, I said, that's fine and dandy. They wanted to get this old, more meaningful data thing, you know, that they could compare. But I said, I think this is trying to tell you something, what the infantry board people had already discovered. You don't see these things at 300, beyond 300 meters away. They said, well, the only thing is that they knew is it was given an unfair advantage, so therefore they changed the rules of the test to include these white targets.
Is this a problem generally in military testing, that if you can't meet the requirement, you change the requirement?
Generally, that's universal. I would say they do it almost every time. It depends if they have an alternative or some other reason for doing it, but I ran into this situation several times since then on tests that were much more elaborate than those first tests at Fort Benning. Not only here, but other countries too. And the testers, being type numbers people and all, get very, very concerned when they don't get any hits on these targets. So they say, in order to get more meaningful data, let's change the rules a little bit, because they figured getting the hits was more meaningful than being realistic.
Stop there.
Stop giving them.
Simple, huh?
Okay, we are rolling and recording.
But I thought, well, that's very simple. We'll just make that the safe then, because it's the most likely way to get knocked off. And everybody was happy.
Okay, tell us how you managed to get lightness out of your weapon through the use of aluminum, but still get the necessary strength and durability.
Well, basically, to do that, you still have to incorporate in the locking system, the lockup system that takes the high pressure. You still have to use a good alloy steel. So that was what brought about the choice of this front locking bolt system, because it allows you to take and make with a front locking bolt, it allows you to take and make what we call a barrel extension screwed directly on the barrel out of an alloy steel that will take the firing loads, and then that's held into the aluminum receiver and lower receiver, and these become more or less housings, and they don't really take high stress loads except under abusive handling. So that was kind of the key to getting the thing light. There again, this alloy that we use has about the same tensile characteristics that rifles used to be made out of in steel. In other words, around 75,000 psi, and your old steels, like we call cold rolled, or the normal steels, in the old days were in the 60 to 70,000 range. So this material really has come a long way in aluminums. The other thing that it's not too apparent on it, but the fact that using this construction technique, these are what we call precision aluminum forgings. They're done in a closed die, and all this outside you see here on the weapon isn't machined at all. That's just as it comes out of the forging die. So it saves a lot of the machining time. Basically, you're only machining around the edges and inside. So it's a way of forming a part that's modern and whatever. Of course, we use in the metal, in the trigger parts and the hammer and all these little bits and pieces, use precision castings or investment castings, which are actually an old art. It really got started in a big way in the dental business, making bridges and so forth for teeth. They actually developed the method of getting the real precision.
Now, you also went to a different type gas system in the AR-15, AR-10 series. Yes,
I did. That was brought about by the fact that a few years back, some of the criticism, I think if you went back to, say, the argument between the Johnson rifle and the Garand, which was some years back, one of the things against the Garand rifle was the bent operating rod that went around corners and everything, and created some problems besides not only adding weight but also put high eccentric loading on some of the parts it was trying to operate. And I was trying to come up with some gas operation method where you could actually keep all the driving forces and everything in line, so as the weapon got fouled up or whatever, or lack of lubrication, you weren't forcing eccentric loads and therefore having high bearing loads. And this system is what I finally came up with. A lot of people have the mistaken idea that this is similar to another system that used a gas tube coming back. Escapes me now. What was the name of that?
Ljungman.
Yeah, the Ljungman type. And the Ljungman type, though, actually made this gas tube came back and actually blew in a little recess in the bolt carrier. and pushed right up here back on the bolt carrier. This doesn't do that. This is just a transfer means of getting the gas down in between the bolt and the bolt carrier, and those two elements then make a piston and cylinder. So in effect, the actuating forces are directly concentric with the cartridge case and the rest of the mechanism.
So that's like a little internal combustion engine.
That's right. And these two little holes here, as the thing opens up, are exhaust ports to let excess gas flow through and help keep it clean. And that happens to be coincidental with the ejection port when all that occurs. And this system evolved. One of the first weapon I ever made, it was kind of a far-out approach to this. You still use this arrangement of this piston and cylinder, but I actually brought the gas tube out on the side of the receiver and just let it bleed right in through the side of the receiver and had an opening matching hole here on the side. And the gas would literally, at a very high pressure, would jump through the gap and pressurize this internal thing and operate the gun. And the first weapon I ever made in this principle worked that way, and it worked pretty well. It had one added benefit. It would blow all the dust and dirt out of the gun, but also was rather obnoxious because you got gas in your eyes and in your nose and everything because quite a bit of it leaking out. Then I took and the next step was putting a little bracket on the side and doglegging in a little nozzle that went down and through a hole in the side of the bolt carrier here and back. So it was really a side mount thing, and some of the very early AR-10s were made that way. Then finally evolved into this system, which was much easier to make and eliminated a part and going straight back into this key. The key was necessary anyway. But the use of the front locking bolt was the biggest factor of making a lightweight system. And then they actually saved a little weight also by going through this gas actuation system. It allowed you to get overall slightly lighter components.
How did you slow that bolt carrier mechanism down as it recoiled to the rear?
Okay, we are rolling and recording.
You have the straight line stock there, and you have the bolt going back into it. How do you slow that bolt down as it moves to the rear?
Well, basically, it's the biggest slowdown comes, of course, from the fact that it's going against a large driving spring, which has to return the mechanism into battery. And there is a buffer, which is actually dampens out the rebound velocity of the bolt going forward. So you're using the driving spring to slow it down on its way back on the stroke. Then when it hits the rear, the buffer then cushions the blow of that whole bolt group going back to the rear. Then that's, of course, one thing that was changed in the later versions when they went through the difference in propellants, which is a whole nother story. The system got faster and faster because of the pressure time curves on the propellants, so they had to go into a heavier bolt arrangement. In fact, some of the newer ones are even going into a hydraulic system, which is a much more complex but makes slower action.
What is the advantage of having the buffer behind the bolt as opposed to having a driving spring attachment up in front of the bolt?
Well, in this case where we're trying to maintain this straight line of arrangement to control the recoil, the rise on the weapon, trying to get the center, of resistance up to where your forces are applied. We had all the space available, so it was just a nice, convenient place to put a spring and a buffer in line. You also, there again, you eliminate the off-center loading, and you can make the parts lighter, a little more effective. You don't have any bind by having eccentric loading in the system. So it's less apt to give you trouble in, adverse conditions.
Now, the early AR-10s and AR-15s have the sort of chromium-colored finish to them. What's the story behind the finishes you use?
Well, there again, I borrowed off the finishes off this with the, just like the alloys, with the experience I had in some of the aircraft equipment, where we had to go through salt spray tests and all the adverse tests that you normally get, and also, you know, try to keep corrosion down as much as possible. And the early ones, the systems we had a specialized chrome finish. It was called electrolyzing. It was a trade name, but what it really was a chrome that was extremely dense, didn't require any undercoat such as copper or anything like that. It could be applied directly to the steel, still would be dense enough to prevent corrosion, and very, very hard to prevent any external wear. And so that's what I put on all these earlier ones. The only unfortunate thing about that electrolyzing process was a licensed process. And I think when Colt went into production, they couldn't get a satisfactory deal with the people that had that patented licensed process, so they went elsewhere and developed their own chrome system. And the fact is, as you know, eventually they quit using it altogether, and I guess they just went to the chrome on the bolt and then the interior part of this thing. The aluminum finishes were what we call a hard anodize. It's actually, there's several types of anodized finishes for aluminum, and this was something that was prevalent in the aircraft industry. It's actually a thicker coating, along with a dry film coating inside to give you some lubricity even when the gun was without oil. So all those things were things that I had previous experience with and just put in there.
Some of the very early AR-15s had the cocking handle inside the carrying handle, as was the case with the AR-10.
Mm-hmm.
Why did that go away in favor of the handle that you have on that one and all the subsequent ones at the rear?
That went away because of the problems in the Arctic. With the full Arctic gear that was required up there with about 3 layers, you know, and ending up with a big mitten with no fingers in it. We had to come up with a system that you could charge the weapon with those Arctic mittens on. So this allows you, with just a thumb and a mitten, you could charge the weapon. And that was the main reason that was adopted, the experience in the Arctic.